Hi everyone. In this discussion, we are looking at a form factor and ripple factor for rectifiers. We'll be looking at full wave and half wave rectifiers. So ripples are the oscillations that are obtained in DC, which are corrected by using filters such as inductors and capacitors. These ripples are measured with the help of the ripple factor and are denoted by gamma. Ripple factor tells us the number of ripples are present in the output DC. So the higher the ripple factor, the more is the oscillation at the output DC, and lower the ripple factor, the less is the oscillation at the output DC. We will see that the ripple factor is the ratio of the root mean square value of the AC component of the output value voltage, the DC component of the output voltage. So ripple factor RF is equal to VRMS out of VDC. So let's look at for half wave rectifier, we'll see that the ripple factor is going to be VRMS. VRMS for a half wave rectifier is the same as Vm divided by pi. No, this is Vm divided by 2. So Vm is the peak DC voltage, or what would be the same as the peak AC input, or the peak of the input AC voltage. So now this is divided by, if we got VDC, VDC is the same as Vm divided by pi. So what will this be? This is going to be Vm divided by 2 times pi divided by Vm. So when this and that cancel, we'll have finally the ripple factor for half wave rectifier will equal to pi out of 2, which is the same as 1.57. So the ripple factor for a half wave rectifier is very high as 1.57. So let's look at the ripple factor for full wave rectifier. So we know that this is the same as VRMS out of VDC. VRMS for a full wave rectifier is the same as Vm divided by root 2. So if we multiply it by, let's divide it by Vm, Vm divided by pi, but 2 times. Remember, the average DC output of a full wave rectifier is twice Vm divided by pi, and this is equal to Vm divided by root of 2 times pi divided by 2 Vm. So what is that going to be? If I get pi divided by 2, then I divide it by root of 2, I have the RF for full wave rectifier equaling to 1.1. So that's where the 1.11 comes from for the ripple factor for a full wave rectifier. So let's look at the form factor. Form factor is also the ratio of RMS value, the DC value, but this is how we calculate it. Form factor is equal to the square root of VRMS squared minus VDC squared, everything divided by VDC. So this becomes square root of VRMS squared, minus VDC squared divided by VDC squared. If I do it like this, then it still means this. So what does that mean? I can still say form factor is equal to square root of VRMS squared divided by VDC squared, okay, minus VDC squared divided by VDC squared. So this is the same as square root of VRMS divided by VDC squared minus 1. So what is that going to be? So for half wave rectifier, form factor is going to be, we said, VRMS divided by VDC is the same as ripple factor, which is 1.57. So we shall have square root of 1.57 squared minus 1. So 1.57 squared is 1. I take root. So I will have 1.21. That's the form factor for half wave rectifier. So for full wave rectifier, form factor is equal to square root of VRMS divided by VDC squared minus 1. Remember, VRMS divided by VDC is the same as ripple factor, and ripple factor for full wave rectifier is 1.11. So this is going to be square root of 1.11 squared minus 1. So 1.11 squared minus 1, I take root of the answer, I have 0.48. So form factor for full wave rectifier is equal to 0.48. So this is where the 0.48 comes from. So in this video, we have seen how we can get the form factor for both full wave rectifier and for half wave rectifiers. Thank you.